Hey everyone, today we're going to be talking about floor finish add-in. In this first part, I'm going to demonstrate you what it can do and the challenges that you may face on your way of actually achieving something like this. So yeah, without further ado, let's get started. And before watching, please, if you find this content useful, please like and share this video and subscribe to my channel. So I'm gonna start this by the external tools. So I've built this that way, but you can also create a new tab with a new panel, right? So it's up to you. So when you run this, you will be prompted with this window, and you can pick up the finish type that you would like to go with, right? So for example, wood finish. Here you can see what options you have. For example, because our floor finish will include the depth of the doors, right? So you can go with full depth, half depth, and without depth. So for example, here the user can select, for example, half depth. You also can select, like, if you want your finish to sit at a top level, right? And you go with finish. When you click finish, you prompt with selecting only rooms, right? So you cannot, if you go with this cross selection, as you can see, something like doors, walls are not going to be selected. So you selected only the rooms, you go with finish, and all finishes will be built, right? So as you can see, all of them are built with the including the doors, right? So as you can see, that's quite helpful. The second scenario where you may have different options, right? Again, I'm going to be using shortcut. So this one. Here we can also have the scenario where here we would have the option where our finish go to the full extension, right? So for example, full depth. Let's go with like wood finish again. Yes, create. So here and here we will have to the full extension, right? And here that will go without any extension, right? So again, I'm going to be using shortcut. We can use here without depth, and let's make your tile, right? Let's go with finish. Let's finish this one. Let's select this floors, hide. Oops, I haven't selected this. Yeah, hide. So as you can see, these are wood finishes that are having the full extension, and this one just doesn't have it at all, right? And also the third scenario where you have one room, and within this room, you can have different scenarios, right? So what do I mean? Let me show you. This is where you need to click on combine selection. So basically, when you click on combine selection, now you're not worried about the finish type, you're just worried about option. So for example, you go like half depth, you click combine selection, you can only select doors, right? So for example, I want to select 3 of these doors. That will go to the half depth. Then you go and tell that, for example, this would go to the full depth, right? Combine selection again. This would go to the full depth. This again to the half, right? This again to the half. This, for example, this will be without, right? So you can go here, click without, and this will be half, right? So let's do something wacky. Half, and that will be full, like this one. Okay. Gosh. Okay. So now I've selected everything. Now I can select the finish type, for example, tile. Yes, now this options will be ignored because you've pre-selected everything. You go with finish, select the room, and now you have something like this, right? So here it goes to the half, here it goes full half, and here it goes like nothing, half, and the full extension. So this is something that you will do on your own, right? Of course, in the next video, I'm going to show you the code, like the implementation of this. But now I want to show you the challenges that you may face and how you can do it on your own. Why am I doing this? Because if you really want to learn how to code for Revit, it is vitally important that you learn how to solve problems instead of just coding along. Coding along is cool when you just get started, but when you have some background, some basics, some basic knowledge, it's really important that you practice and learn on developing your programming skills, right? So basically, these are the steps that you would need to follow to do something like this, right? So the first step is to get outer and inner loops for your floor. So whenever you have a problem or like a task, for example, you know that you need to do something, but you don't know how to implement this. First of all, you can always Google it. There is that guy, Building Coder, I think, an amazing guy who shares a lot of knowledge, and you can get a lot from his blogs, right? So your main goal is to learn how to Google. So you can, for example, you don't know how to solve a particular challenge, you just Google it, find some answers, but always look for the Revit API docs. I think it's important to understand why you're doing a specific thing, right? So let me show you. If I go, oops, not this. So here Revit API, right? So here you can look for any kind of information. And on my way of explaining things, I'm going to show you some examples of why you would need to go there. So for example, this challenge, right? So basically somehow basically everything is based on the room, right? As you saw, right? So basically the idea is to analyze the room and get some information out of this. So our first goal is to get just the inner part, the outer part of our floor. Of course, it's based on what version of Revit you're using, right? Because now I'm using 2021, where you cannot build a floor using a couple of boundaries, right? Like outlines. So you cannot, let me kind of go with floor. You cannot do something like this with Revit API, right? So what I achieved here is by creating openings. So if I run this one more time, let me show you so you can understand. So like wood finish, half depth, okay, finish, select this room. As you can see, I have openings, but these openings are made that way, right? So when I select boundary of the room, it goes like this. So, right? But what you really need to know is that, as you can see, this is the boundary of your floor, of your room. So basically, this is the first thing that you need to read. Whenever it comes to analyzing information of your room, the first class that you should learn about is the spatial element geometry calculator. Actually, there's a lot of classes named like spatial element geometry and something that can be like results. So read up on this, Google it, learn how to search for information, so that way you can become better and better at it, and you will be able to solve problems on your own. So this class is used to calculate the geometry of a spatial element. Spatial element, it's a room. So when I go to the Revit API and I type room class, right? Oops, room class. I hope you're familiar a little bit with C# and object-oriented programming, because that is vitally important to kind of just learn about Revit API. So as you can see, room class, here you have the inheritance hierarchy. So we have the architecture room, so that is basically your room class, but that is inherited from the spatial element. So if you're not familiar with the object-oriented programming and inheritance, to put it simply, inheritance is just for us the way to reuse code. So for example, spatial element is more of a general one, right? Because as you can see, spatial element is inherited from element. So we have the most base element, right? So for example, just element. the spatial element inherits from element, meaning that it's more specific. It's not just element. So element is more of an abstract, right? So each hierarchy is being more focused on something, right? So for example, element, if I go for element, and you can see the hierarchy that I have, as you can see, it's a lot of things right there. So almost all the elements are inherited from this one. So first of all, you need to understand inheritance, right? So here you have element, then we become more specific, and that will be spatial element. Then we have area and architecture room, right? So as you can see, it's more of a general because it includes room and area also, right? So basically, my architecture room has all the things that spatial element has, because we don't want to reuse that code that we implemented here in spatial element, right? And as you can see, this spatial element can have like something like get boundary segments. So this is for you to explore. So if you go and try to analyze like everything, go and Google it, you will be able to later on look for information on your own without just coding along. So learn about spatial element geometry calculator and think about the way how you can get the outer and inner curves, right? And here subface type, which is an amazing property that will allow you to pick up the bottom subface. So you need to know a little bit about enumeration, right? So if I go here and type subface type, as you can see, that's an enumeration. So basically these are some static members, like the ones that are not changed. For example, like categories in Revit, right? They're not changed. So as you can see, these are the geometries, the subface types. So yeah, let's go to the next one. So your first challenge is to how to get the outer and inner curves, right? The second step is to know what doors the room has, right? So if I go to Revit and you specify the room, so you have here the room, right? It has like some doors, but you need to learn, you need to know how to get these doors, right? Based on the room that you have, right? And be aware that there is a method called get generating element IDs, right? If you're not familiar with this, like don't worry about it. I'm gonna show you everything in the next video. I'm just showing this for people who want to do this on their own, right? So if you want to do this by get generating element IDs, keep in mind that a wall can go through a lot of rooms. For example, corridor, right? So what does it mean? Get generating element IDs is a very cool method when you want to get openings from the wall, right? But here this room has this wall, and that wall has this opening, and this opening. So you need to filter that way that you would get only this one. So yeah, you can use the power of bounding box, right? I hope you're a little bit familiar with bounding box, but again, to put it simply, it's just the bounding box is the box that has that cannot be kind of rotated, right? It follows so imagine that you have a coordinate system, right? So Revit has a coordinate system here, and if I go to hide, as you can see, that is my origin point, right? And global coordinate system in Revit is a static one. It's immutable. You cannot change this. It goes to the X goes to the right, Y goes here, and Z goes up, right? So Y goes kind of up if you're watching from the level, right? From the floor plan. So basically your bounding box cannot be something like this, right? So it can only be this way, it cannot be that way, because actually that follows the the directions of your x, y, and z. So if you have a coordinate system that has a direction of x here, you can only, of course you can rotate it, right? Just go there and rotate it. But imagine how complicated that can be to understand the rotation of each kind of stuff, right? So maybe that is not the best solution. But there is a way how we could actually do this. So yeah, bounding box has the same vectors as the coordinate system, right? So this means if you get a bounding box over rotated door, you will get something like that. So here I've showed you that if you do have a door like this, you will get a bounding box that will look that way, which is not actually what we want. So, but now it's time to learn about symbol geometry and an instance geometry of a family instance, because that can be so helpful. If you think about this, your instance geometry is just the geometry of your door. So for example, if you have this door and you get the instance geometry, that will be placed right here. So it is just the representation of your door itself in this environment, in the project environment. But if you go and go with the symbol geometry, again, you need to download Revit Lookup. It's really important. So here, as you can see in add-in managers, I have this lookup. You can Google it and find a GitHub, and there will be an instruction on how to download it. But the idea is like this. Oops, oh my gosh, I double clicked. Okay. So when you go to Snoop current selection and you go to the oh gosh, I think it's geometry, right? Geometry, right? And here you have an option for the instance geometry and symbol geometry. Symbol geometry is the representation like as if that would be in the family environment, right? So if I were to display that geometry, that would be something like this. So that would be represented that way from the coordinate system, right? So that would be in that place, right? With the correct dimensions, of course. So basically, that will ignore the actual rotation of your instance. It will just represent it here, right? So it will store that here. And that is quite powerful because now when we have a geometry here, we can actually get the bounding box, because again, the bounding box follows the like the vectors of your coordinate system, and because that is located here, right, we can get the correct dimensions, right? So getting symbol geometry and getting the bounding box of your symbol geometry will allow you to obtain the bounding box with the correct dimensions, right? So that can be quite cool. The next thing, but now you may think like, but how do I get this bounding box, right, and move it here, right? Because I actually need to have it here. What you really need to think about is that each element has a transformation. And a transformation, basically, you just really need to learn a little bit about what is a local coordinate system, and basically just what is a coordinate system. Four main things that you need to know about coordinate system: that origin, it has origin, and 3 directions, right? So what does it mean? That it doesn't mean that your coordinate system should be always straight like this, right? It can be rotated, right? So for example, this door has a transformation, that door has a transform. So if I go to the Snoop current selection of this door and get total transform, as you can see, this my 4 main criteria, right? I have basis X, basis Y, and basis Z, which basically is telling me where my basis X is pointing. If you think about the global coordinate system that Revit has, it points just to the right. It would be like 1, and Y also 1, right? But this one is telling me where my X is pointing, where my Y is pointing, and where my z is pointing, right? And that has an origin. So basically this basis x and basis y and basis z is helping us kind of get place our bounding box properly, because that means if your x is pointing that way, right? Oops. If your x is pointing here, that means that this side of the bounding box is going to be like here, because again, it follows the direction of your main coordinate system, right? You just need to play around with this, but the point is like this, that by getting the simple geometry, you can actually pick up the geometry in its representation, like as if you would have this in the family environment, right? Not rotated, just like as if that would stay put, right? So that can be kind of quite helpful. And then by getting the bounding box of this, you can move it and do some stuff like with this. So you can change the transform of this. Let's go to the next portion, right? And here I've actually talked about just what I explained. And the third step is to get the outline, including the depth of doors. Right, so basically when we create, as you can see, if I go and I create again, so I go with that in manager, and for example, it doesn't matter, have depth, right? Also I can go with the full depth. So as you can see, this is what we have. So I've done this with the help of the bounding boxes, but actually how we can get this outline, right? And the trick for you is that you can create your own class of a bounding box, right? That will inherit from the already existed bounding box, right? So if you go to Revit API and you type bounding box XYZ class, that means that class, right? So here we have a constructor. So basically it has a default constructor. It has some methods and properties, right? Like transform, right? So we can change the transform of the bounding box, right? And here's some properties, but you cannot change the width of this. You cannot turn this to solid, right? But sometimes this is something that we want, because, you know, actually if you have in your door something like moldings, your dimensions will be incorrect. So what I did, I've changed all of the dimensions based on the host door, right? So I've just grabbed this bounding box and changed the dimension of it based on the width of the wall that door is in, right? So basically you need to create your own class of the bounding box that can be turned to solid, that can be right, you can change the width, height, length of this, right? So just take a piece of paper and just draw this and think about how would I implement this, right? Try to think about, but how could I even change the alignment, right? So if I have this that way, right, how I can make that would start from the bottom, right, or from the left corner, right? So this way you can really kind of work on problem solving. So by doing this, you can easily build everything. So now when you have the outline of your room, and now you have the solids of your bounding boxes, right, of your actually the families that are specific to some room, meaning that you have the outline, for example, for this room, you have the solids for each of the door. Now you can actually extrude this by having an outline, you can extrude it and get a solid actually, right? So if you go with the create extrusion, so here go with the create extrusion, right, geometry, you can just extrude this by having a list of curve loop, right? And then you can join the geometry, right? So here you need to also learn about how you could actually create this union solid of a lot of solids, right? So really think about this. What is the best way of doing this? Google it, right? How to create a union solid. You will definitely find something, because that is the way I solved it. So, um, so yeah, just look it up and you will find the answer. But I'm going to show you everything in the next video, but I really want you to just do it on your own and then look for the solution I came up with. So that is the way you actually learn, when you do it on your own and then see like what other options do you have, right? So yeah. So basically, I think I've covered everything that I wanted to about this, right? So basically here are all of the steps that you can actually do, but also keep in mind that you would need to solve the issue with the bounding box origin, right? So because what happens here is that you create a solid geometry, for example, right? But as you can see, I could have just went with the full depth or with the half depth. So this is done by leveraging the power of changing the solid of the origin of the bounding box. So think about it too, right? So your class of the bounding box extended should have this implementation for changing the origin. Actually, I'm sure that on your way you will face even more stuff, right? But this is the way you can learn. So here I've just prepared for you a task, and if you really want to do this on your own, that will be so beneficial for you, because you will learn how to Google it. You will learn how to find some information in Revit API docs, right? So if you're dealing with elements, but actually start with the Revit lookup, because it's going to be easier for you. But actually, to put it simply, for example, you have a door, and when you go with the Snoop current selection, first of all, it's going to show you the properties of the element, because that is the base class for all elements in Revit. So it's more of an abstract class. If it's more of a, it's like a shape. Imagine that you have a shape, and that is more of an abstract class. When you have something like a rectangle, a triangle, that is more of a specific. So these classes like triangle would actually can be inherited from the shape. So yeah, so here as you can see, you have the element properties and methods, but also you have the methods and properties relative to the family instance, right? So that is, so you can scroll through this, you can find some information, for example, get subcomponents, like the symbol of this, so you can just go through this and find any information that you need. Also, you can ask some questions in the comment section below, right? I'm gonna help you with this. Of course, there's gonna be a next video about how to do this, but please try to do this on your own. Because learn how to solve problems, don't just code along. But keep in mind, in order to make this challenge interesting, that should contain 5 to 10% more of your current skills, right? So don't beat yourself up, right? If you cannot solve this, just watch the video and you will just learn a lot from this and how to do this. But if you have some background, if you know some basics, it's going to be so beneficial for you, because it's like a task. You can really do this for 1 week, maybe for 2 weeks, but once you solve this, that will be so rewarding, right? The cool resource that you can check for doing this is that website, is that blog actually, from the geometry, and here you can learn about geometry analysis. A lot of stuff is here, actually everything related to the geometry. You can learn pretty much like really a lot of stuff, but find what you really need, right? So for example, here you can find get generating. I think I can look here or not. It's gonna go there. Okay, I cannot look for this, but okay. So get generating element IDs, right? So here you can actually read about a lot of stuff, and here you can see some code. Here you can find about this spatial element calculator. As you can see, yeah, this is where it is. So as you can see, it's code really about this spatial element boundary options. So you can find this, you can follow this, you can learn a lot from this, and just this way you will really get a lot of stuff and learn like tons of things. So basically that's it for today. Again, if you find this content useful, please like and share this video. And yeah, thank you for watching. Have a nice day.